Good afternoon, and welcome to the American Floral Endowment Grow Pro webinar series. I'm your moderator, Gareth Chamberlain. I'm a biological scientist working with Dr. Lanar Layton at University of Florida IFAS North Florida and Research Education Center. I earned my bachelor's in environmental science from Florida State University, and I'm currently studying environmental horticulture as a graduate student at the University of Florida. Today's session is on fine-tuning your greenhouse controls for the young plant season. On behalf of the Endowment, I'm excited to be part of AFE's Grow Pro webinar series that features a new topic every month presented by an industry expert. The webinars are free to everyone thanks to the generous support of AFE's sponsors. The views and opinions expressed in these webinars are those of the speakers and do not necessarily reflect the views or positions of AFE. As an independent nonprofit, AFE cannot endorse any specific product or opinion. Today's webinar is sponsored by Smithers Oasis and Syngenta. Smithers Oasis is a diverse global manufacturer and marketer of floral foam and design media, floral design tools and accessories, post-harvest products, cellular growing media, temperature control packaging, and custom foams for specialized applications. Syngenta is a global leader in agricultural innovation, and they are focused on developing technologies and farming practices that empower farmers so that they can make transformations required to feed the world's populations while preserving the planet. If you'd like to learn more about our sponsors or are interested in becoming a sponsor for the topic, you can find that information on AFE's website at endowment.org/GoPro. Today's session was pre-recorded in English by Dr. Paul Fisher. After the presentation, Dr. Fisher will join us for a Q&A. Feel free to submit your questions through the Q&A feature or chat at any time. We'll answer as many questions as we can before the end of the hour. Unanswered questions may be answered through a separate email exchange. This session is being recorded and will be shared to the AFE's YouTube account. Through YouTube's accessibility features, you can access closed captions in other languages. To get started, I'd like to share a bit about today's expert speaker. Dr. Paul Fisher is a professor and extension specialist for floriculture crops at the University of Florida. He collaborates in multi-state projects on applied research for the greenhouse industry, including the Floriculture Research Alliance, Clean Water 3, and Resilient Plants Project. Dr. Fisher also leads greenhouse trainings online and is currently developing mobile accessible grower training and calculators to help growers to improve production efficiency with information technology. Dr. Fisher, welcome and thank you for presenting on today's Fine-Tuning Your Greenhouse Controls for the Young Plant Season.
All right, well, thank you very much for that introduction. My name is Paul Fisher from the University of Florida, IFAS Extension, and I'm going to talk about fine-tuning your greenhouse controls for the young plant season. Be a little bit of a combination of some tips for getting ready for growing your transplants in the upcoming season, as well as one or two research projects that we're involved that are related to that. And the key point I want to make is just a bit of preparation is going to avoid surprises for the coming season. This is the period that we're going to make the most money in the year. And we know that controlling the environment is the key to having successful rooting on your plants and the profitability of this season. So you want to make sure you've got training, the people side, equipment, and also the sensors in place to control those key environmental inputs: water and humidity, light, and temperature. And why should you care about this topic? It's because we're plant factories when we're manufacturing transplants, and stress equals variability, which increases costs of production. And those costs could be through increased crop losses, the extra labor, which is limiting for all of us in terms of grading and fixing trays. And we're looking for uniformity. Every tray is the same across the bench and across every week of production. So what are some of those environmental parameters that we need to have at an optimum level? One of them is going to be light. This was some work I did a few years ago with CubePack, one of our partners in the Floriculture Research Alliance, where we looked at growth of seedling plants with and without electrical lighting. And of course, extra light means extra photosynthesis, means extra growth, more compact plant, more roots. And that's not just true for seedling plugs. This is research work from Michigan State University, and I collaborate through the Floriculture Research Alliance and Floriculture and Nursery Research Initiative with my colleagues at Michigan State University, Roberto Lopez and Eric Runkle. And what they showed very clearly is as we go up in daily light integral and moles per square meter per day, up to a certain limit, we get much faster rooting. Faster rooting means more crop turns and more uniformity, more profit during our winter season. When it comes to irrigation, both myself with Dr. Kate Santos, we looked at water use and leaching and propagation, and also my colleague Jim Faust at Clemson University. And we looked at how much water was being applied in cutting production for a range of different growers. And these are all very good young plant growers. And what we find is that between the driest and the wettest growers can apply 10 times more water than the drier growers. And what that means is, okay, all of these growers are producing good quality plants, but our system is designed to handle overwatering. And in general, if we can minimize the amount of water that's applied, just enough to hydrate the plants and provide the water that they need, we're going to get faster rooting and more root growth. And water is cheap. And so the reason to conserve water in young plant production is not really water conservation, although of course it's a limited resource, but really the costs of overwatering are very expensive. For example, in the bottom left, you can see a scavola, which has got callus on it. It's 3 weeks old. It's got a saturated soil, and plants need air. They need drier soil to be able to produce roots. Otherwise, they'll sit there being calloused. You can see Ipomea here, where foliar rot. And on the right-hand side, from my colleague, Dr. Rob Wick, an example of a Pythium-infected root system. And Pythium is a water mold. And all of our root pathogens are favored by overwatering. So the costs of overwatering are really in terms of production costs as opposed to the water itself. So what we're going to cover is 3 different key points. One is we need to have our team ready. We need to provide training and have a plan. We need to look at our irrigation equipment and controls, and the same thing when it comes to climate management, especially light, temperature, and relative humidity. So when it comes to training, this is probably our best training method that was developed by industry on the language of how wet is wet, the 1 to 5 moisture scale, 1 being bone dry through to 5 being saturated. And we can use that moisture scale in a crop plan. So this is an example from Dr. Will Healy, based on a program for several seedling plug crops at Ball Tagawa Nursery in Colorado, where as we go through different stages in the crop development from left to right, from germination through to toning, then we have different moisture level targets at which point we're going to irrigate. So for example, at stage 1, it would be for germination and tending to be a higher moisture level. At stage 4, as we tone the plant, try to get compact, harder tone on the crop and force that plant to grow roots, find the water, then we have a lower moisture scale, a drier substrate. And the same thing can be applied to a typical plan for annual cuttings. So we can define different stages from hydration to callus to root initials, root growth and hardening off as we go down this table, and we can define moisture levels. So you can see that we're starting more saturated as we've got callus and hydration, and then we move into starting to dry the substrate down to grow roots, and then we go through wet-dry cycles as we try to harden off and get root growth on the crop. And we can also define some other environmental parameters. I'm not going to go into those in a lot of detail right now, but the handouts are going to be available. American Floral Endowment is providing that as part of one of the resources from this presentation. So just to mention, we're going to talk about VPD, vapor pressure deficit, a little bit. Low VPD means high relative humidity, often cooler temperatures. RH there is relative humidity, the amount of water vapor in the air temperature, the substrate temperature, and the light, both in terms of daily light integral, moles per square meter per day, and also the light intensity level at any moment in time and micromoles per square meter per second. We'll talk about some of those parameters later, and you can refer to this table from the handouts. And of course, not every crop is the same. We have, for example, silver-leafed plants like helichrysum that are going to require less water than a lantana or a verbena, for example, under mist, and also different periods of moving through the different stages. So, for example, a poinsettia is going to take a longer time to root than a petunia will. And so the timing is going to vary. So you need to have a plan. Now, one of the things is we've got some resources that are available for training. I have a research extension appointment at University of Florida. So we have a number of resources. There are also other excellent resources from other universities, such as the eGrow set of resources that are available online. But one of my websites is called backpocketgrower.org. And in there, you'll find a number of free calculator apps, for example, for fertilizer dilutions. There's videos, for example, this video on the 1 to 5 moisture scale. There's fact sheets as well. Everything on my website's in English and Spanish, and so you can access the fact sheets for training for the coming season from backpocketgrower.org. We also offer some 4-week training courses, and this is something where American Floral Endowment supports the program. So each year we apply for an education grant, and AFE has been very generous in its support there. And we've also had a donation from Ken and Dina Altman, the owners of Altman Plants in California, to expand our number of courses. So these are 4-week certificate of completion courses from University of Florida IFAS Extension, but we have instructors from multiple universities, and example courses coming up over the coming year would be Greenhouse 101, Climate Management, Irrigation, and Substrates that are all very relevant to the talk that I'm presenting today. So the website's there, hort.ifas.ufl.edu/training. This is not just for Florida growers. We get about 30% of our participants are international, 30% Spanish speaking, and from all over the US. So consider that for your staff training. And then we have another new training series that we'll be launching at Cultivate in 2025. And this is very basic. It's a train the trainer for your staff to train for your growers to train your staff on how to water. And we've got some very practical mix of online resources, short videos, and then guidelines for hands-on activities that you can do to provide staff training. So check us out at Cultivate in 2025. It's called the Professional Irrigator Training Series. It's a hybrid between online and you being the professors within your own operation. Okay, so let's switch from training to irrigation. We've already talked about irrigation, and bottom line is that irrigation all relies on trained staff, no matter how many sensors and level of automation that you have. But let's go through some tips on delivering and controlling irrigation for young plants. The first is that you need to start the crop, fill your trays at a target moisture level. And so that's typically going to be about 55 to 60% moisture level by weight. And there's there are training resources for that. They're available for free in backpocketgrower.org. And this is a hand test that you can use to train your staff that are filling flats in your operation. And many growers will put a photo of the target moisture level up on the hoppers in the flat filling line. Similarly, we can have a target moisture level when we are sowing or we are sticking cuttings. And so what many growers will do is they'll take a postal type scale, costs around $100, $150, an LCD display, put it near the sowing line. Every moisture level, 1 to 5, that we mentioned has a certain weight for a particular kind of tray. So you can know pulling out trays on a periodic basis to make sure that plants are going into the germ room or out into the greenhouse at the target moisture level. Another training tip is, this is something that Kate Santos and I did, is we went out and we put these little trays that we got from Walmart to collect water that had leached through mist propagation trays. And we did this under mist, and we also did it off mist where growers were controlling the irrigation with booms or hand watering. And we collected the amount of water that was going through, washing through that substrate. And basically, we want to try to minimize leaching because it's going to wash out nutrients. So what you can do is you can put it out there, again, use this as a training tool for your staff and talk about how much water is being washed through. As soon as we have about a half gallon or 2 liters per tray washing through any of the pre-plant nutrient charge that you've got in your media, if it's water-soluble fertilizer that's been added, hasn't by now been washed out by the mist water. Another good tip that I learned at 4-Star Greenhouses from Dennis Crum up in Michigan was to check underneath the trays to make sure that we're not over irrigating. And so if this is particularly good in the morning to check your night misting, going out, lifting up trays, what we want to see is we want to be able to see some moisture under that tray, but ideally under every one of the drain holes, not a saturated puddle, and we don't want it completely dry and having stressed plants in the morning. So again, this is really a training tool and also something and when you're doing your walkthrough with your staff, to go through and just evaluate whether the right amount of moisture is being applied during the night. Now, something that we've done with our Floriculture Research Alliance growers over the past 2 years is we're trying to fine-tune the boom irrigation. And so what we do there is we run a boom over a series of trays that don't have holes in them. And we do it 6 times so that we can kind of even it out. And then we measure how much water is in every tray across the boom. And that's useful to know what the average is, how much water is being applied per pass, per mist event, and also to know how variable it is. So this is a way to check for clogged or worn emitters and also to see how much water is really being applied. And when we looked at 12 different grower locations, each boom pass was between 5 to 24 milliliters per tray, per boom pass. That means that some growers were applying 5 times as much water with a mist event as others. And our overall guideline would be half as much, twice as often. And so that would mean only having a small amount of water being applied to the surface of the leaves so you can get evaporative cooling off the surface of those leaves, and applying that more often rather than a few heavy passes when it comes to cuttings. And so many of the growers reduced the amount of water being applied per mist event by either changing the nozzle type or a faster boom speed, and then they could also adjust the number of boom passes per day. So a teaspoon per boom pass would be about 5 to 10 mils, and a cup per day would mean that we're applying somewhere 200, 250 mils per day per tray. And so the other piece of information that you need to know if you're trying to quantify how much water you're putting on through your booms is you need to know how much water gets applied per boom pass times the number of mist events per day. And that'll give you the total volume. And so again, growers vary a lot. We've seen from 30 to 105 boom passes over a tray during the first week of mist. And so in this case, it would be 50 boom passes, 10 mils per boom pass would give you 500 mils. That would be a pretty heavy application for February in most grower locations. So the next aspect about irrigation then is scheduling when the booms pass over the plants. And there's a lot of factors that really affect how quickly a cutting dries down. We'll focus in on vapor pressure deficit, which is the combination of air temperature and air relative humidity, sometimes leaf temperature, and also light, because those are some factors that are important in terms of having sensors that we can use to control control the timing of booms. But there are other factors as well. For example, if we can minimize airflow, then we'll reduce evapotranspiration rate. We won't need to pass the boom over as much as we needed to. And so in general, what we're trying to do is to create an environment where we have slow drying under mist. So that would be high relative humidity, moderate air temperature, moderate light, and low airflow from fans and ventilation. So what we did was we went to 14 different Floriculture Research Alliance growers. These are all young plant growers at a large scale, and looked at how they control their booms. And 6 of them were with a time clock, so they were relying on an experienced grower to go out and adjust the timing on the boom, sometimes having up to 4 different periods, morning, midday, afternoon, and night. 7 of them had vapor pressure deficit accumulation and 1 had accumulation of light, so they were using sensors. The light modifiers would mean that we're using VPD, air temperature, air relative humidity, but when there's more light, then the controller accumulates VPD with a multiplier more quickly. And many of these growers, the majority, have the irrigation booms, they're controlled separate from the environmental control system, such as an Argus or a Preva or a Damatix and so on. But 6 of them had those irrigation booms integrated in with their environmental control system, so they could use the sensors both for environmental control as well as irrigation control. And what I would say is that you can't do as good a job with a time clock as you can with a climate-based scheduling of boom irrigation. It's just not possible. And what will happen is when you get really busy, which means the time that you have the most greenhouse, the greenhouse is at its fullest and you're making the most money possible, is when you have the least amount of time for an experienced grower to go out and tweak the time clock. So climate-based irrigation, whatever system you choose, is definitely a step up in terms of scheduling. But just be aware that as you add every additional sensor, there's a cost and a risk associated with it. For example, many growers, their air relative humidity sensors aren't really working very well. The leaf temperature sensors that most growers use are not really very good for young plants. And if they're irrigating based on light, you really need a light sensor inside your greenhouse, but most growers actually rely on a weather station, a light sensor outdoors. So my current recommendation would be, the ideal would be a combination of air vapor pressure deficit with a light multiplier. Okay. So talked a little bit about VPD already, vapor pressure deficit. And the concept here is, very simple. When it's warm and when the air is dry, we're going to have fast drying conditions. And it's very like having clothes on a clothesline. A t-shirt on a clothesline is going to dry out more quickly with a windy day, with a sunny day, with a warm day, and in dry area in Arizona rather than the swamp of Florida, for example. Okay, and the same concepts apply to a greenhouse with a cutting dry. And just looking at air temperature and relative humidity, we can calculate VPD, vapor pressure deficit, and there's a number associated with it. And again, backpocketgrower.org, under tools and climate and vapor pressure deficit, there's an English, Spanish calculator where you can enter in, for example, 60% relative humidity, 68 degrees Fahrenheit air temperature will calculate a VPD of 0.96. Well, is 0.96 good or bad? Well, we can compare those VPD numbers with some targets for propagation or for production. And so what we're seeing here in this table is from the top to bottom, it's cool to warm. From left to right, it's dry to moist air in terms of relative humidity. And there's these different VPD levels. And ideally, for mist propagation the first week, we would have a VPD that's less than about 0.7. But really, you can manage a higher VPD, even up to 1.5 if you really had to. But you're going to have to apply more mist because you're going to get more drying. When we have plants off mist, then we have a higher VPD target, meaning we want drier air. Okay, and so that's going to drive water uptake into the plant. It's going to drive nutrient uptake. It's going to give us a harder tone. So we can interpret this combination of air temperature and air relative humidity in terms of VPD. The units I'm using here are kilopascals, and you might be more familiar with millibars. So 1 kilopascal is 10 millibars. But the bottom line is, whatever way you use climate, what we're trying to do is match the drying condition over the course of a day. So we go from 8 a.m. to 4 p.m. We're going to get the most drying in the middle of the day, of course. And so we want to, one way or another, whether you're manually adjusting with different time periods on a time clock, or you're using ideally a climate-based controller, you want your system to be applying more mist in the middle of the day when we've got the most rapid drying. And there are different options that are out there. I don't have time to go through the pros and cons of all of them, but I'll just give you a basic concept of how these different climate accumulation programs work if you don't have one now and you're considering making that move. So basically, with a time clock, we accumulate time. We accumulate minutes and seconds and hours, and we have set points to say, okay, we're going to accumulate a certain number of minutes, and then we're going to trigger an irrigation event. And we'll probably have a different set point at different times of the day. With climate accumulation, you pick units of millibar minutes for VPD or millimoles per square meter for light, and you accumulate those climate units. Think of them as drying units. And sometimes, as I mentioned, you can have combinations of different factors, vapor pressure deficit and light. And that's certainly a capability in, for example, an Argus or a Previs system. And so basically here, what I'm showing is on the left-hand side, the minutes time since the last irrigation event. And then we might be measuring VPD every minute and accumulating that as millibar minutes. And we might have a set point of, for example, 75 millibar minutes to trigger an irrigation. And we might have as a backup to say, oh, we'll never wait more than 15 minutes. And so basically what will happen is once that sensor reaches, in this case, after 9 minutes, we've reached 75 plus millibar minutes, we're going to trigger an irrigation. But if we had very low VPD, then it might wait until that 15-minute threshold before an irrigation occurs. Okay, we talked about water, irrigation. Now we'll move to climate and sensors. And this is a project that is a collaboration with Dr. Ying Zhang, who's from Ag and Bioengineering at University of Florida. And it's a program called Precision Propagation. Actually, it's led by Dr. Selena Gomez at Purdue. And Daniel is one of my master's students, and he's looking at sensors and sensor use in propagation greenhouses. So the key sensors that you want to check that you have in your greenhouses ready to go for the coming season is air temperature, a reliable relative humidity sensor, and ideally a photosynthetically active radiation, power, light sensor indoors in your greenhouse so that it's measuring the conditions that your plants are experiencing. I'm not going to go into any detail, but we also look at other sensors. So for example, Daniel's been looking at an infrared temperature sensor that measures the surface of leaves and of the cuttings or seedlings in a tray, and it's actually been very effective, and we've tested it out with several of our FRA growers. Okay, air temperature and relative humidity. Air temperature is generally pretty simple to measure, but the key thing is that you want to have a shaded sensor, so it's not got sunlight directly on the thermocouple or thermistor, and it needs to be aspirated. In other words, it's got a fan that's moving air over the sensor to be more representative. And you may need more than one air temperature sensor per zone, because some of our zones now are very large in some of our greenhouses. Sometimes we have what's called a wet bulb and a dry bulb sensor, for example, inside that Preva box that's in the top right. And those are designed to have a dry bulb is the same as a regular air temperature sensor. Wet bulb has got a wick with an evaporating surface with the sensor, the temperature sensor inside it, and so it's measuring the temperature of an evaporating surface. And there's a relationship between those that is used to calculate relative humidity. But one of the problems is that many times when you go and check this wet bulb sensor, the reservoir is empty, there's no water in it, or the fan is not working to really get good evaporation. So if you have a wet bulb, dry bulb temperature sensor for relative humidity, you need to check that on a weekly basis, because otherwise trying to calculate, for example, VPD, vapor pressure deficit, based on relative humidity, it's just not going to work. So then the other option is to have an electronic relative humidity sensor. And these have a use by date. So the propagation environment is very harsh for sensors, and check that these are working, especially if they're older than 2 years. And what I do when I visit growers as a consultant is I take along a calibrated relative humidity sensor. Some growers will use what's called a sling hygrometer, which are $100 to $200. And so for grower visits, I use a NIST calibrated, it's a standard calibrated temperature relative humidity sensor, and compare my readings with what's coming from their environmental control system. Now, what we tend to do, because we're so busy in the peak, is we tend to just rely on our environmental control system to do the right thing. Open vents when we need to, turn on LED lights when we need to, turn on the subfloor heating, and so on. We're so busy, we often don't get time to really look at our data. And we get these line graphs and masses of numbers, but we don't take the time to really review the numbers, interpret them, and act on them. For example, to know whether the shade is coming over at the right light level. So one of the things that we're doing is we're trying to interpret with a dashboard some of this climate data. That's a research project that we're working on now with growers, and more to come on that. This is part of Daniel's project. But we can define set points, and we can interpret the information and correct problems before they affect the rooting and growth of our plants. And the key point here is take the time as a head grower to check your data every week for climate management. And here's just an example. Here is air temperature during February of this year from one of our growers. And what you can see is that we've got some limits here in terms of air temperature. And early in the season, you can see that at night, we're dropping down to 60 degrees Fahrenheit, which is too cold for rooting cuttings during the first week of misting. And then what you can also see is that as we got into the second half of February, we were starting to get some pretty warm temperatures in this greenhouse, over 90 degrees. What's likely to happen then is we now start having to vent. So we're probably got a combination of heating and just environmental warm temperatures. If we're overheating and then having to ventilate, we're spending money on heating fuel, and then we're blowing it out the window literally. Okay, so relative humidity, what we want to look at is, are we maintaining relative humidity in a good range? And so this is from a different grower here. You can see their air temperature data look very good, but they're getting pretty high light levels in here. And one of the problems in this greenhouse here is that they are ventilating when the light is getting high, and their relative humidity is plummeting down to sometimes 30% relative humidity. What that means is the vapor pressure deficit is now getting very high. And so in these conditions, even though this is February, we need to add some extra shade here, because otherwise we're having to ventilate too much, and we're going to be having to run our mist a lot. We're going to saturate the soil and leach it out. Okay, let's look at light for a moment. The most appropriate type of light sensor that we have, of course, is not going to be foot candle and lux. That's visible light to our eye. It's going to be a quantum meter, or a PAR, photosynthetically active radiation meter, that measures in micromoles per square meter per second. Those are the units that all of the researchers are doing work on light with because it's what directly affects photosynthesis. And when we are talking about light, there are two very important related and different aspects. One of them is the light intensity at any moment, which is the micromoles per square meter per second. And you can think about that as how hard is it raining right now? And then the other is the accumulated light over a course of a day. That's the daily light integral. And think about that as a bucket that's collecting all that rainfall. And so we have moles per square meter per day for daily light integral. And so what we want to do is we want to have in our greenhouse light sensors indoors, under the glazing, under the shade system, under the LED lights that are actually measuring light level at the level of the crop. This is Tom Gunter at Lucas Greenhouses in New Jersey demonstrating exactly how to do that. So you want to have a light sensor for photosynthetically active radiation inside your greenhouse because the temptation is to overshade, make our plants too comfortable, which will lead to lower photosynthesis and delayed rooting. And we want to transition from lower light to higher light as we're toning off our plants at the end of the crop, getting them ready to be able to resist transplant and shipping into the final container. So what I see is lots of investment on LEDs, okay? But if you're spending money, $50,000 or more in a bay, then you want to measure the light level because it's like having a sports car without a speedometer. This is Noah Duranian from Pleasant View Gardens demonstrating the importance of measuring light under your LEDs. Okay, so you really need to know, after making all of that investment, how well you're controlling light level. And of course, there's opportunities to improve efficiency, not run your LEDs if you're getting enough sunlight, for example. You can only know that if you've got a sensor inside. Here in Florida, we get quite a lot of sunshine. It's the sunshine state. And so for us, it's not just electrical lighting, it's also the shade level. And when I came down from New Hampshire to Florida, many of the growers down here were overshading, and I would see light levels in Florida in February that were similar to light levels in New Hampshire at the same time of year because there was too much shading. So really think about your shade. Is it past its use by date? Okay, has it got algae or dust on it? Is it a heavy shade level, too heavy? And do you know what the actual transmission is and the light intensity and DLI that you have in your greenhouse? And that's the way to choose what percentage of shade that you have. Is it uniform across the bay? Are you adjusting as you go from summer to winter shading? And in winter time, then to a large extent, then we can open that shade and make the most of our sunlight, which is free light energy. And finally, as you get closer to toning at the end of the crop, are you transitioning to a higher light and different shade settings? Now, American Floral Endowment funds a lot of great research. Okay, this is an example from Roberto Lopez, my colleague at Michigan State University. And it's showing different daily light integrals as we go from left to right with rooting of osteospermum in Nemesia. And to be able to use this research really in your greenhouse, you have to have a light sensor inside the greenhouse. Okay, so you may look at all this great research work going on, but to implement it, you just need to spend the money to get the measurement. In God we trust, all others need to bring data, right? And so when we're looking at light in a greenhouse, there are several aspects that we need to measure. We want to measure daily light integral for growth. We want to measure the light intensity at any moment in time to know, are we getting enough photosynthesis? But we don't want to have peak light levels that are really high and are going to stress our plants. Okay, and so on the right-hand side, these are several of our Floriculture Research Alliance growers that I work with. This is the DLI, daily light integral, that we actually measured in February this year, and the peak light intensity. And so let's just take an example of grower number 4 here. What you can see is that they need to adjust their shade. The peak light intensity inside the greenhouse got up to about 4 times more light than they need. Okay, so they needed to be shading at that point because there's probably plant stress. Grower 7's interesting. They had a very high DLI. They had LED lighting. They could probably back off on energy costs of lighting because they're more than providing enough light for, for plant growth. They're exceeding the required DLI for young plants. So analyzing the data has really great possibilities for saving on energy costs. So I'm going to finish on this slide. It's really when we're coming into young plant season, we want to get ready. And that means training, it means equipment, and it means sensors. And we're balancing some different factors. We're balancing light for growth, heating of the root zone for root growth. We want to minimize air movement, ventilation to retain humidity. We want a moderate vapor pressure deficit so that we don't have to run our booms a lot and saturate the soil and leach out the soil. And ideally, we'd move towards climate-based irrigation. So hopefully you got some ideas for those different areas, training equipment and sensors from this talk. I'd like to thank the Floriculture Research Alliance supporters that fund my students for this on-site research work. You can see it's very applied, and we work directly with these excellent growers and allied companies. And I'd also like to acknowledge the sponsors for the GrowPro webinar series and mention that next month on January 28th, my friend and colleague, Dr. Ray Cloyd, will be talking about mealybug management. And with that, I think we might have some time for questions. Thank you.
Dr. Fisher, thank you for your presentation. I'd like to open up the session for Q&A now. So our first question is, how do you connect irrigation boom controls to your environmental control computer?
Yeah, thanks, Gareth. So several growers that I've worked with have got solutions that they've worked with their environmental control companies and their boom companies to get these two different systems to talk together. And it all depends on whether you've got Argus, Prevo, Damatec, some other system, and what your actual boom company is. But there are electronic boxes, you could say, that allow the systems to talk to each other. And so, for example, you can use the temperature and relative humidity sensors, light sensors that you already have for your environmental control system, and you can set up program that to trigger a range of different booms through this box connector, sometimes called a spooler. And so I would really encourage you as growers, if you're wanting to get your system truly integrated together, find a grower who's got one of these solutions or talk with your environmental control or boom company and see how that communication can go ahead, because solutions are out there, and I think it's a very good way of pulling all of your sensors and equipment together.
Thank you. Our next question is, how do I know how much light I need from LEDs and propagation?
Okay, so one of the things to think about with light is going to be the light intensity that you have at any moment in time. And so we talked about there's some targets that are in the slides that AFE will provide from here. But for example, we're typically up to somewhere around 300 micromoles per square meter per second. And so if you have a more adaptive system of controls, then you can have a light sensor in your greenhouse that is measuring sunlight and know whether or not the LEDs need to be turned on. So that's one aspect to it there. There's more efficient LED control systems than just saying, okay, I'm going to turn it on, for example, from 4 in the afternoon till 10 at night. So take into account sunlight. There's also in Back Pocket Grower, there is a calculator that allows you to put in the number of hours you're operating LEDs and the light intensity, and that'll tell you how many moles per day you'll be contributed by the electrical lighting. And then the other thing that you want to know is this DLI, Daily Light Integral, and there are standalone little weather stations available from suppliers such as Apogee Instruments or Spectrum Technologies, on-set computers that you can put into your greenhouse. But even better than that is to have a light sensor tied into your environmental control system, and that can generate a report for you on the computer.
Sweet, thank you. I've got another question. Would you give some tips to avoid condensation on plants in colder environments?
Yeah, so when we get condensation on leaves, it means, which is usually at night, it means that the leaf temperature, the surface of that leaf has got colder than the dew point temperature. And so this is really a good way to do a deep dive into looking at the temperature and relative humidity levels that you have in your greenhouse. And so basically we have the air temperature, and that'll be our dry bulb temperature. Okay, and then we can calculate with the relative humidity at what temperature can the air no longer hold all of the water vapor in it, and the water vapor now starts to become a liquid on the leaves. So what we basically want to do is to make sure that our leaf temperature doesn't drop below the dew point temperature. So a couple of aspects of that. One of them is to go into the night period with lower relative humidity. That means that that's going to drop the dew point temperature. You may have less risk of condensation. So that would mean, for example, venting at the end of the day. And replacing the moist air in the greenhouse with drier air from outside. Another, of course, is to heat above, make sure that the leaf temperature is above the dew point by providing heating at night. And I mentioned that we're doing some research work on leaf temperature sensors, and the best kind of leaf temperature sensor is an infrared sensor. And you can contact me if you want information about sensors that we're using, but they're only about $300 and can be tied into to some environmental control systems. So you can know what the leaf temperature is. And then the final tip, just in terms of management, is increasing air movement is going to reduce the amount of condensation on the leaves.
Thank you. Our next question, what would you say some of the most common mistakes that growers make in preparing for the young plant season?
Well, I would say the biggest one, the by far the most common one, is not fine-tuning the irrigation booms and resulting in overwatering. That's the most common. And then the other one I'd say after that is that some equipment fails. It inevitably does. There's so many moving parts in a modern greenhouse, and not having the preventative maintenance now in December for when things get crazily busy in January. It's so often that, as a consultant, I kind of go in and do a spot check sometimes with young plant growers, and without I don't want to critique everybody because it's just so busy, but it's very common that I'll see, for example, that perhaps the floor temperature is not coming on as planned, and the soil is down at 60 degrees Fahrenheit, where we're wanting it to be above 70. And so we've had a couple of weeks in January, February, where we've got delayed rooting. So preventative maintenance and checking your irrigation system are really two of the keys.
Thank you. Our next question is, when and why is it important to have a leaf temperature sensor?
Yeah, it's a great question, and I'll be providing more grower articles over the coming year about leaf temperature, because we're really doing a deep dive in it. One of the reasons is that when we talk about photosynthesis, for example, which drives growth of plants, the most important temperature is not really the air temperature, it's not the root temperature, it's the temperature of the leaves. And so that is actually the parameter that's most important. That drives the biochemistry inside the plant. And the leaf temperature is very rarely the same as the air temperature. Because, for example, at night, for example, there might be evaporative cooling from the plant, so the leaf temperature gets cooler than the air temperature around it. When it's sunny in the middle of the day, the leaf temperature might get warmer than the air temperature. And then, so it affects photosynthesis. It also affects drying of leaves and the need to apply mist. And so there's, when we look at tomato growers or monoculture vegetable crops in the Netherlands, where they're really optimizing their growing system, then leaf temperature becomes a really important parameter they'll measure. Just give you one more example is if the plant is drought stressed, it doesn't have enough moisture, then it can't cool itself by evapotranspiration. It's like us not being able to sweat, to perspire on a hot day. So the leaf temperature is used compared with the air temperature by some of these vegetable growers to get an idea about drought stress and water status of plants. We have a lot to learn with young plant production to apply some of the same concepts.
Thank you. Our next question is, when are the online training courses going to be available?
Yeah, thanks for that. So we'll do our announcement in February, and we'll put out a press release. And I saw in the chat that mentioned that there are discounts for American Floral Endowment supporters for our courses, and we really appreciate AFE supporting the program that we have. And so yeah, look through AFE announcements and also other press releases in February. And we're adding 3 new courses next year. And they're not just from University of Florida. We've got instructors from about 10 different universities that contribute to our program.
Thank you so much. And remember, we put your questions in the Q&A and in the Zoom chat if you have any available questions. I have a question. What kind of cleaning measures do you use in your greenhouses to prevent algae buildup and other like mold related issues?
Okay, so sanitation for your greenhouse, not something I mentioned in this talk, but it's something we do a lot of work on algae control. And so one of the first things is in between seasons is a great time to be able to clean out your irrigation lines and without worrying about all of the goop that comes out of biofilm affecting your crop. So one of the things would be to shock your irrigation lines with a line cleaner and then completely flush those out. Clean up your individual emitters. And one of the things is that the biofilm from last season is a source of spores for spreading algae for the coming year. And then when it comes to all of your greenhouse surfaces, the off season is a great time to first clean and second sanitize. And then, one of the other things that we look for, Gareth, is when we've got an algae problem in a greenhouse, we try to figure out what is the source. So it could be the biofilm that's already existing in the lines. It could be dirty floors from last year, or it could be the water source. And so I'll just mention, one of the websites that we have is called cleanwater3.org. It's got information about controlling algae spores and biofilm in your irrigation lines, but sometimes it can be necessary to inject on a continual basis a sanitizer such as ozone or an activated peroxygen product or chlorine dioxide to keep those lines clean and avoid spreading algae.
Thank you. Our next question, if the leaf is the same temperature as the room, what could I do to cool it down?
Well, one of the things, when we're misting, then what we typically think we're misting for is to add water to the cutting to keep it hydrated. And it kind of is. But the biggest effect of mist is that it puts a small layer of water onto the leaf, which immediately starts to evaporate. And it means that that's going to humidify the microclimate, the air around the leaf. But it'll also cool the leaf down. And so, we've done infrared video of a boom passing over a young plant crop. And immediately after the boom passes, the leaves cool down, can be up to 5 degrees cooler. It's amazing how quickly that happens as the water starts to evaporate off the surface of the leaves. So a short answer is misting or using a sprinkler to get evaporative cooling is one of the main ways to cool leaves down. Another one is that if you've got really warm leaves in the middle of the day, and the leaf temperature is warmer than the air temperature, it may mean that the plant is under drought stress. It can't take up enough water quickly enough to be able to open the stomata, the little pores in the leaves, and cool itself down. And so one of the other keys is to make sure that when you've got the most stressful conditions, of course, that the plants are well irrigated. Another way of cooling the leaf down is shading. And so that's a big way that shading helps to reduce stress is radiant heating from the sun. Just like if we're out in the sun versus the shade, same thing happens. It's like the skin for a human is the same as the dynamics of what happens to leaves. So providing shade's another way to cool leaves down.
Thank you. Our last question, based on your experience, what is the best heat type infrastructure to keep soil temperature for rooting stations?
That one, I'm not a greenhouse engineer, but what I can see is there's a lot of advantage in having some form of bottom heat for multiple reasons. We've got a very small plant, and we're really trying to manage a microclimate. And so if we provide, whether it's subfloor heating on a concrete floor or fin pipes underneath wire benches, then, if we're heating the soil, then we are heating the plant. And, we've looked at a number of different greenhouse operations and put sensors in different places. And if you wanted to have one parameter that would predict the plant's temperature, it would be the soil temperature, because those plants that transplant seedlings or cuttings are so close to the soil. And that means you don't have to heat all of that extra space in the greenhouse environment. So some form of subfloor heating. And then, it's also interesting, some research work from Dr. Roberto Lopez with LEDs, showing purpling of some petunias and some other plants under LED lighting for cuttings. And one of the solutions there is simply to warm them up, and bottom heating would be the most efficient way to do it.
Thank you so much. Thank you for joining us today for another session of AFE's Grow Pro webinar series. Join us next month for Dr. Raymond Cloyd's presentation on mealybug management on Tuesday, January 28th at 1 p.m. Eastern Time. You can register at endowment.org/GoPro. While there, check out our past webinar recordings. other grower-related resources, and resource reports available to you for free to thank the industry's support. We also have recently released the new schedule for 2025 Grow Pro webinars, and we encourage you to check them out and register ahead. This webinar concludes our 2024 Grow Pro programming. If you have found these webinars valuable, we encourage you to make a donation to AFE to support future research. The link will be in chat. We ask you to please complete a brief survey about today's session where you can suggest additional topics and help us continue to improve these webinars. Thank you again for joining us. Have a great day.